In the previous two videos, looking over our retest review for our retest on limits, we discussed how to compute limits. We discussed how to talk about limits existing, as well as how to work with determining when functions are continuous. And lastly, we're going to talk about the intermediate value theorem. Okay, so here we have a situation that we're told to use the intermediate value theorem. And we're told that we want to show that this function f of x has a 0 on this interval. Okay, so for the intermediate value theorem, there's a couple of things that you have to consider. All right. One thing to consider is that f of x is continuous on your interval. All right? And for us, because f of x is a cubic polynomial, f of x is continuous. All right. The next thing we want to do is to evaluate our endpoints. All right. And so that means we need to figure out what does f of negative 3 equal, and we need to figure out what does f of negative 2 equal. Well, if I input negative 3, that's going to be negative 27 plus 9. Negative 2 times negative 3 is positive 6, and then plus 2, which I know is less than 0. If I substitute in negative 2, that's going to be negative 8 plus 4 plus 4 plus 2, which I know is greater than 0. So therefore, since f of negative 3 is less than 0, but less than f of negative 2, and f of x is continuous on our interval from negative 3 to negative 2, by the intermediate value theorem, f of x is equal to 0 somewhere in the interval from negative 3 to negative 2. All right? So in other words, the intermediate value theorem is a concept from algebra that relates continuous functions. And it says, hey, if I have a continuous function, right? So if I have this function that I can draw without lifting my pen or pencil, right? I can think about it conceptually. And I know that the value of my function at one point is less than 0, and the value at another point of my function is greater than 0, then somewhere in between my function had to equal 0. And that's all we're saying here, right? That the value of my function at one endpoint is less than 0, at the other endpoint is more than 0, and my function is continuous. By the intermediate value theorem, my function has to equal somewhere in the interval, right? And really and truly, if I knew that this interval over here was the f of negative 2 was actually equal to 2, and the f of negative 3 was actually equal to, let's see here, 9 and 6 is 15 and 2 is 17. So f of negative 3 is actually equal to negative 10. Right? So we know that from negative 10 to positive 2, that f of x must equal every value between negative 10 to positive 2 if my function is going from a value of -10 to a value of +2. I don't know how I get from -10 to 2. All I know is that I must go through every value between them. And that's working with the intermediate value theorem. So hopefully you feel prepared for the retest. Thank you very much for your time.